Alright, today we're going to look at finding the rational zeros. So we're going to add on one extra piece from what we were doing in 5.5. In 5.5 they gave us a starting point, and this time we'll have to find the starting point on our own. So we're going to find the rational zeros. Here's the rational zero theorem. Basically what it says is P is the constant term, Q is the leading coefficient. That's what you really need to know. So we're going to take the constant divided by the leading coefficient. And we're going to do all the factors, which you'll understand when we do an example. But that's what the rational zero theorem says. Here's an example. So we're going to start with this problem here. All right, and so the constant is negative 12, and so that's why it goes on top, because P is negative 12. The leading coefficient is 1, and that's why 1 goes on the bottom. So now what we have to do is we have to find all the factors of 12. So we have 1 and 12, 3 and 4, 2 and 6. So those are all the factors of 12, and we put plus or minus in front of all of them. Okay? Then we do all the factors of Q, which is 1, which is just plus or minus 1, so that was easy. And then we list them all down. So I have the 12, the 1, the 2, the 6, the 3, and the 4, and then I divide them all by Q. So these are all the possible rational zeros that we could try that would be solutions of this problem. So now we actually have to see which ones work. All we need is one of them to work, and then we can factor to find the rest. Usually what I do is I just start with 1, because those usually end up being the most common ones that work in Algebra 1, or Algebra 2, sorry. So we start with synthetic division. So we have our stuff that we did before. We have the P's and the Q's that we just found. We have the synthetic division, so we listed all the leading coefficients. Okay, so now we're going to try 1 first. Drop down the 1, multiply 1 times 1 is 1, 2 plus 1 is 3, 1 times 3 is 3, negative 8, negative 8, negative 20. So this does not work because we didn't get a 0, so 1 is out. So then the other option here is the negative 1. So now we're going to try negative 1. So I'm going to bring the 1 down. Negative 1 times 1 is negative 1, add. Negative 1 times 1 is negative 1, add. Negative 1 times negative 12 is positive 12, 0. So now that we have a 0, we don't have to mess with those rational zeros anymore, because what we have left, we can actually factor. So we take this guy, we write him as a polynomial, just like we did a couple sections ago. We factor, just like we did yesterday, and we set him equal to 0, just like we did yesterday as well. So the only thing that we added on was the beginning part. Everything else stays the same. So our solutions are negative 4, 3, and then the negative 1 that we found that worked up here. Alright, so let's try our problem all the way from the beginning. Okay, so this time it looks just like this. It didn't give us any starting info like they did yesterday. So first thing we have to do is figure out what P is. P is equal to 30. That's the constant. Q is equal to the leading coefficient, 1, the number in front of the guy that has the biggest exponent. So now we have to list all the factors of 30. So we have plus or minus 1, plus or minus 30, plus or minus 2, plus or minus 15, plus or minus 3, plus or minus 10, plus or minus 5, plus or minus 6. So you're just going through all the numbers that go into 30. And then we divide them all by the factors of Q. So 1, 1, 1, 1, 1, 1, 1, 1. Okay? So now we need to start with one of them that works. And again, I always start with plus or minus 1 for some reason. So I'm going to start with 1. All right, I'm going to list the coefficients 1, negative 4, negative 11, 30. Drop down the first term, 1. Multiply, negative 3. Add, and then negative 3, negative 14, multiply, so negative 14, that's going to make not 0, so 1's out. So now we're going to do negative 1. So 1, negative 4, negative 11, 30. Drop down the first term, 1. Negative 1, negative 5, 5, negative 6, 6, 36. So he's out. So now we have to go to the next one. I'm not going to do 30 because that's likelihood of it working is pretty small. So I'm going to do 2. All right, so 1, -4, -11, 30. Bring down the first term. 1, multiply 2, -2, -4. That would make -15. Multiply, that would make -30, 0. Finally, we have one that works. That's all we need is one of them to work. We don't have to plug any more of those rational zeros in. So now we're going to take this guy and we're going to write it as a polynomial. So x squared minus 2x minus 15. We're going to factor what two numbers multiply to make -15 and subtract to make 2. So -5, +3. Set them equal to 0. X is equal to 5, x is equal to -3, and then our 1 from the beginning, x is equal to 1. So we have 3 solutions because we had a cubic equation, which means it has 3 solutions. So if we have a graphing calculator, or you can use graphsketch.com, I'll write that up here, or if you have an Android, you can download an app called Wabbit. It sounds really funny to say, .emu, and it's actually a TI-84 emulator, which is kind of cool, and it'll give you a little TI-84 on your cell phone if you have an Android. We didn't see one for iPhone, but we did get one for Android, and it was free, so even better. So if you have an iPhone, use the graphsketch.com, and if you have a Android, I would suggest that you see if you can download the TI-84. Go to that wabbit.emu in the Google store and see if you can download it. So what we can do here is we can shorten, instead of having to find all those rational zeros, we can look and actually see what they are. So this is -3, this is 2, and this is 1, 2, 3, 4, 5. So we can actually just see the solutions instead of having to do all that work that we just did. That's why having a graphing calculator is so cool. That's also why we graph, because that's a visual representation of the solutions. That's why they call them zeros, because they lie on the x-axis where y is equal to 0. All right, so let's do this one. If you have a graphing calculator, what you do is in your, you go to your y equals part, which is right below your screen on the left-hand side, and I'll show you how to do this tomorrow. And you have an X key, and then you have one of these keys, and you hit 3. So if you can't figure out how to put it in your calculator, don't stress. We'll do that. And this is the same way that you plug it into the graphsketch.com or the emulator if you downloaded the app. Okay, and then you graph it and you look and see where it touches the x-axis. So I'm going to pretend like I don't have a graphing calculator. I'm going to do it using the p's and the q's. So p is equal to 9, q is equal to 1. So I have all the factors of 9, plus or minus 1, plus or minus 9, plus or minus 3. I don't have to write the 3 twice, even though 3 times 3 is 9, because I already wrote it down. So divide them all by the q, and these are all the numbers I'm going to try. So I'm going to try a +1 first. If you graphed it, you can just look and see, does +1 work? If it does, then there's no reason to even try it, if it doesn't work. Alright, so bring this down, 1, 1, 0, 0, -9, -9, 0. So what this means is that the graph does touch the x-axis at 1. So now we set this equal. We can skip the x because it's 0. So now we factor. Set each factor equal to 0. Solve for x. I always like it when the first one works. And then we have the 1 from above that we got. So these are our 3 solutions. Right? And if you graphed it using graphsketch.com or the emulator or your graphing calculator, which again I'll show you how to do in class tomorrow if you're confused or don't know how to do it, it's no big deal. And then this is where it touches the x-axis, or those 3 points. And that would have saved us a ton of work. In class, we're going to do these problems, right? And so if you're not going to be there tomorrow in class, you're going to need to do them on paper. We'll probably do them on whiteboard so that we can just kind of get that immediate feedback. All right?